How's it going, everybody? In this video, we're going to take a look at the adjacency process like we did with RIP and Eigrp so that we can understand the process of how the adjacency is formed and all that stuff that goes along with it. So we're going to spend a little bit of time breaking down that process, and then we're actually going to go talk about some of the different variations of how this actually works. So let's go ahead and dive into the theory real quick. So basically the way this works is you get a situation where you have a couple of routers, right? You have, R1 and you have R2, and they are linked together like so. And I want to form an Eigrp adjacency between the two. Well, there's a couple different ways that you can do this. The first way that we're going to talk about is with multicast. We're going to use multicast, and again to the 224.0.0.10 address, which means that the TTL value here will be equal to 1, which means when I send out a hello this way to this multicast group and R2 receives it, he will be able to respond back to that multicast message and say, yep, I'm here, I see you, and everything is good. But the source IP will be of whatever R2's interface IP address is set to. So let's say, for example, this is 10.1.2.0/24, and this is .2, and this is .1. If I was to ping 224.0.0.10, what's going to end up happening is you're going to send a hello to this address, and then anybody on that link that's listening to that group will respond to it. But the responder, so basically the ping reply, will look as though it's coming from the other router. Because what ends up happening is when you enable the protocol at the interface level, you are basically joining on both ends of the link the 224.0.0.10 address. So think of this as a joined multicast group that both ends of the link are going to go ahead and join. Now, the way that this works is when you do this, you have to use the network statement, right? You have the network statement configured. And if I do this, when I go to configure this, I need to enable the network statement. The configuration that I use needs to match an interface that is got an IP address associated to it, that is in the up state. It's in the up state. So if you're up, and you've got, say, 10.1.2.1/24 associated, you'll be in good shape. Now, the network command itself, when you type in the command network, say 10.1.2.0, let me clean that up just a little bit for you, 2.0, 0.0.0.255. What that basically is saying is this is the wildcard. A wildcard is the opposite of a subnet mask. So a subnet mask for the same thing would be something like this, right? So these two equal the same thing. Whereas 0 means I care, and the 255 or any other variable for that matter, this could be a .3, a .31, a .63, it doesn't make much of a difference, means I don't care. Okay? So basically what we're saying is the first 3 octets here we care about. So as long as the other end of the link is something along the lines of 10.1.2. something, where in the fourth octet this could be any address of 1 through 254. Okay? As long as the fourth octet is set to this value right here, then the IP address in this range here doesn't make much of a difference. It could be .1, it could be .2, it could be .57. We don't care. Okay, that's how the network statement comes into play. Now, if you need to form an adjacency and not leverage multicast, so for example, you want to send a connection over in a link that maybe multicast is not enabled on. And there will be scenarios where you run into where multicast isn't going to work, and stuff like that. So you need to basically set up a unicast connection over whatever transport it is you're leveraging. So you might be like, well, what might that be? Well, the old school mentality would be like frame relay, where you didn't, the provider is not allowing multicast communication over frame relay. So no broadcast is enabled. So because multicast is a subset of broadcast, you wouldn't be able to send the traffic over the link via multicast. You'd have to send it via unicast, which unicast doesn't rely on multicast for communication. It just sends it directly to an IP. You could say neighbor and whatever the IP address is. That sets up a unicast peering. So EIGRP is possible with this. OSPF is possible. Unlikely that you're going to see this type of stuff in the production world, but in the event that you do, now you know. So that's basically how that comes into play. So that's basically what we're going to be taking a look at as we go through and set this up. So what I'm going to go ahead and do is I'm going to go through and talk a little bit more about getting the configuration up and running. There's a few things that we must agree on. The first thing is going to be the subnet. So must agree on, and that's going to be the same IPv4 subnet. That means that if I've got R1 and I've got R2, and this is 10.1.2.x, and then I've got R3 down here running 10.1.3.x, and then 10.2.3.x, that if I want to form a connection via router 2 and router 3, then I must enable EIGRP on any links enabled on those interfaces, or any interfaces with that IP address associated to it. That's the first thing. Same thing with the connection between R1 and R2. This must agree, and same thing with 10.1.3. So there you go. That's how that comes into play. They need to be in the same autonomous system number. So what exactly is the autonomous system number? Think of the autonomous system number as your EIGRP boundary. So let me go ahead and clear the screen off real quick. If I have R1, R2, and I have R3 laid out like so, and they are all part of ASN, autonomous system number 1, 2, 3, then when I go to turn EIGRP on all these routers, I'm going to use the autonomous system number 1, 2, 3 here, 1, 2, 3 here, and 1, 2, 3 here. That's going to allow them to communicate with one another. However, if I come over here and I do let's do router 4, router 5, and router 6, and then I put them into their autonomous system number of 4, 5, 6, and I run 4, 5, 6 here, and 4, 5, 6 here, and 4, 5, 6 here. They are all going to form an adjacency with each other. However, if I tried to form an adjacency between R2 and R5, do you think they're going to work? Nope, because I've got 1, 2, 3 here, and I've got 4, 5, 6 here. They are not equal. I would need to come up with a third autonomous system number. Let's say we come up with 25. We come up with autonomous system number 25. Then we form an adjacency between these two. So what will end up happening, let me go back this up a little bit. So we do 25 between R2 and R5. Now, we have all this stuff in play. What do we do? Well, in a situation like this, communication from R1, 2, and 3 would work. Communication from R4, 5, and 6 would work. Communication between R2 and 5 would work. But would traffic from, for example, our autonomous system 1, 2, 3 and autonomous system 25, would that communicate with each other? No, it wouldn't. So what we would need to do is we would need to basically turn on redistribution. We would need to go underneath each EIGRP instance and say redistribute to this other autonomous system. The cool thing about it is because it's all EIGRP, we don't really have to do anything other than do a redistribute command. We would just redistribute one autonomous system into the other. Since it's EIGRP to EIGRP, we wouldn't need to mess with metrics or anything like that or do any route maps. If we want to do some filtering, that would obviously need to be configured appropriately. But this would allow us to go through and do the redistribution this way. So then I could do something like this. I could come in and redistribute, let me just draw this real quick like so. We draw a link between the two right here, and we draw this between these two. Let me just clean that up just a little bit. Right, and we do 25 here. We would actually do a redistribution here, mutual between 4, 5, 6, and 25, and then we would do one between these two. So from 123 to 25, we would just do mutual redistribution both ways, and then say the land segment hanging off of R1 would now would be seen from R4's land segment. So now if I had, you know, Bob hanging out here doing his thing, this is Bob, and this is Sue hanging out over here doing her thing. If they wanted to communicate with each other, they would. Now, what would that look like in the routing table? Well, it would just look like an external EIGRP route, that's all. So you would see some EIGRP routes coming in from R5 and go back and forth, and everybody would be happy. I'll demonstrate this when we get a little bit further along in the actual configuration, just to get a little bit more into the weeds of how EIGRP works, but this is a supported design. I wouldn't recommend it. So if you're like, I wouldn't recommend taking the things you're learning for like maybe a CCNP studies or CCIE studies and dump it into a customer's environment. But in the event that you need to do this in order to control the distribution of routing updates, this would be a really good thing for you to do. Now, can you control routes and things like that? You sure can. You can absolutely create a prefix list to filter on what routes you want to limit where they're being learned, and then if you want to use that in a route map during the redistribution process, or set some sort of tag value to say, well, if you receive this tag in, drop it if it's received back in, things like that. So there are ways to mitigate this configuration if you want to do that, but this is a pretty easy way to understand how that process would come into play. So now that we've gotten through all of that, let's go ahead and take a look at some of the details to how all that type of stuff comes into play. Let's go back up here to our config, and let's go ahead and take a look at this. All right, so we're going to pull this up, and what we're going to go do is pull up router 1, XR2. Go ahead and pull these guys up real quick. Oops. Go ahead and that's another lab. Let me go ahead and pull up a new secure CRT window. All right, so we should be in pretty good shape here. We should be able to log in here and do a show IP interface brief and see that all of our interfaces are configured the way that they need to be, which is what we want to see. So I'm going to do some of the initial configs. I'm going to go through and show you how this looks and just get an adjacency up and running and stuff like that. And what I'm going to go through and do is I'm going to get the adjacency between R1 and XR2 working first. And then I'll go through and I'll do mutual debugs on R1 and XR3 just so you guys can see how that process comes into play. So on R1 or iOS 1, I want to form an adjacency between iOS 1 and XR2, but I want to advertise the loopback 0 into the protocol. So a real simple way of doing this would be to go to router EIGRP 1, and I'm going to use, there's a number of options that we have here. I'm going to type in the network command, and the network number is going to be whatever subnet we want to enable EIGRP on. So the simple way of doing this would be 10.1.0.0. Because what we're doing, or 100.1.0.0, which is saying any interfaces that start with 100.1. In this case here, all of my interfaces start with 100.1, right? Everything starts with 100.1. So it's an all-encompassing network statement. And if I come over here to the wildcard, I can type in 0.0.255.255, which is saying any interfaces that start with 100.1, I want to pay attention to. That's what the 0.0 stands for. And then the last two octets, right here, third and fourth, I've got 255.255, which means I don't care what IP address is here. I just want to form the adjacency. So I'm going to hit the enter key there. And so now if I do show IP EIGRP interfaces, we'll see that, let me scoot this out just a little bit more so you guys can see it. We have gig 00 is enabled for EIGRP, gig 1, gig 2, and loopback 0. We're going to talk about some of the interfaces that will be enabled that we wouldn't want to form an Eigrp adjacency over later, but for right now we're just going to roll with it. But if we come over here and do type in do show IP Eigrp neighbors, we don't have any neighbors. And if we look at the topology, all we have is our connected links in the Eigrp database, or I should say the Eigrp table. So what I need to do now is come over to XR2. I'm going to go ahead and log into this guy, Cisco, go to global config, and I'm going to need to type in the command router Eigrp1, and then underneath here we're going to type in the address family of IPv4 unicast, or IPv4, and then we're going to type in the autonomous system number is going to be 100. I think that's what I used over here. Eigrp autonomous system number 1. Okay, so my fault. Do show run section Eigrp. That's probably my mistake. Let me go ahead. It's a very common mistake for me to make. No router Eigrp1, router Eigrp 100, network of 100.1.0.0, and I'll throw that in real quick. So that replaces that command. So underneath here, we're going to type in, with iOS XR, you have to be a bit more specific. Now we're going to type in the interfaces that we want to enable for Eigrp. We'll type in interface. In this case here, it's going to be gig 00000 and gig 0001, and then interface loopback 0. Okay. Now we will take a look at how passive interfaces come into play here in just a moment, but well, I'll talk about that later on. For example, if we don't want to form an Eigrp adjacency between XR2 and iOS 16, that's one way to do that. So we do a show config, right? So now the config is in place. So, but none of the commands are there. So now don't worry about this right here. This is basically saying Eigrp 1 is the name. So if we were to exit out a couple times here and go to router Eigrp and do a question mark, we have just the virtual instance number, right? That's all that really is, the autonomous system number, where the autonomous system number underneath the address family is going to be 100. So if I type in the commit command, what we should get is, after a couple of seconds, this should form an adjacency with iOS 1. It might take it a couple of seconds for it to kick in and trigger, but we should get that. And it's saying that there's a problem. So let's go ahead and take a look at show config failed. Says configuration, configure autonomous system number for default BRF. Oh, that's right, I forgot about that. So no router, let's just abort real quick. I forgot about that. In XR, there's like I'm not sure if it's a bug, but basically we have to come in here and give it a name. So we're going to type in, we'll say AS100, right? And then we're going to type in address family IPv4, and then we'll type in autonomous system is going to be 100, interface gig 0, and then gig 01, and then interface loopback 0, show config. So we have to give it a name and not a number. So we're going to hit commit. That should go through. There it goes. So now that we've done that, we should form an adjacency here with, and we did right there. So we know we have the adjacency good to go there. So now that I have that in play, I'm going to jump out of global config here, and I'm going to type in debug Eigrp packets, and I'm going to hit the enter key here. So it's going to look for a bunch of them. So it's going to start pushing out a whole bunch of hellos. We're going to see hellos being sent out, and we're going to see a bunch of stuff going back and forth. So what I'm going to go do is I'm going to go to XR3 and do the same thing again. I'm going to come over here, log in, Cisco, go to global config, router Eigrp AS100, address family IPv4, autonomous system is going to be 100, interface is going to be gig 0000, gig 0002, and I believe that's going to be a 1 below that, which it is, and then interface loopback 0. I'm going to go ahead and I'm going to commit that config. And what you're going to see over here is you're going to see a whole bunch of information go back and forth. We will see the process come up and figure out what's going on. You'll see some information going back and forth. And basically what's happening here is the adjacency is coming online. The adjacency is up now. So if we were to do an undebug all, give that a couple seconds to finish its thing. What you're basically seeing here is we are sending a hello out gig 00 with a packet length of 20. For AS100, there's no flags. There's 0 sequence, 0 interface queues, no interface. I believe that's inbound. I know this is a database queue for unreliable and reliable updates. So that's where that real reliable transport protocol comes into play. Basically, what we're getting is a received a hello from 100.1.2.2. So we know that there's somebody there. And that's how the other side of the house knows that we're good to go. So if we were to come in and look a little higher here, we will see that we saw some information going out back and forth. They were trying to figure each other out, basically sniffing each other's butts to figure out who's doing what. And then we go through and we see that we have an adjacency go back and forth. So you're going to queue up an update to gig 0/0 to a neighbor of 100.1.3.3 with a topology ID of 0, because you can do multi-topology Eigrp. We're not doing that here. We have in the interface database queue, in the reliable portion of it, we have one update going out. Okay, and we're sending we're queuing the update. We requeued unicast on gig 0/0. We're sending the update, which is in a NIT, and basically we're saying, I'm going to try to initiate a connection with you and send you the adjacency is up, but now I'm going to send you all of my Eigrp information. So basically my topology database. So if I come down here and do a show IP Eigrp topology, we should see a bunch more stuff. We should see router 1's loopback, which is connected and it's a loopback. We should see router 3's loopback, which we do, and we should also see router 2's loopback, or XR2 specifically. And we see all those coming in, and we know where they're at. And that's basically what that basically does. That's really the extent of Eigrp coming up and becoming operational. There's not a whole lot more to it than that. So now that we have that in play, I can go ahead and get the rest of the routers squared away. There is really no way to do a mass config thing, so you can't go to the interface level like you can with OSPF and type in interface gig 0/0 and type in IP Eigrp. You can't do that command here. It's not supported. So what you can do, and let's go ahead and enable Eigrp on all interfaces for iOS 4 without doing a network-specific statement. So we'll type in router Eigrp 100. Now type in network of 0.0.0.0, 255.255.255.255, which basically is saying, I want to enable Eigrp on every interface. I don't care what it is. By doing that, we will form a connection with both XR2 and XR3 respectively. And we just enabled Eigrp on any interface that's got an IP address. We're saying we don't care. Just go ahead and enable it. So we've got that going for us, which we are now squared away with. If I come out here and do a show IP Eigrp interface, we can see all three interfaces are now up and running. We have, I should say, they're enabled for Eigrp, but not everybody has a peering setup. If we do a show IP Eigrp neighbors, we have a neighbor to XR3 and XR2. And if we look at the topology, we should see a number of routes being learned, which we do. I have a couple different paths in order to get to iOS 1's loopback. I have a couple different paths to get to the 100.1.28 network. Even though we don't want that in Eigrp long term, it's okay that it's there. Not that big of a deal. So we have that. So I can go in here and I can go, there's a number of other Eigrp stuff that I can look at. I'm just going to go ahead and go in here and do a show IP route, and we should see a bunch of Eigrp routes in the routing table. So right now, our topology table pretty much matches our routing table, but that won't stay the same. When more and more stuff gets implemented and gets added, a lot of this stuff you'll see a little bit of a fluctuation. When we start messing around with different variables and capabilities, this will fluctuate a little bit. So get a baseline, understand that, and proceed forward. Okay, so the last two that we're going to go set up is going to be iOS 5 and 6. So on iOS 5, we're going to do the same thing. Router Eigrp 100, a network of 100 dot. In this case here, 1 won't work. So I need to come in here, and I'm going to use an even broader, I'm going to be more specific with my network statements because I have more interfaces to configure. If I do show IP interface brief, I have 104, 105, 101, etc. So if I use a really broad network statement like 100.0.0.0 like this, then it's going to enable Eigrp on every interface, and then I run the risk of forming an Eigrp adjacency with somebody I don't want to. So instead of doing this, I'm going to do a 4.5.0, 0.0.0.255. So just that link between 4 and 5. That brought my connection to iOS 4 up. And I'm going to change this one over to be 5.6. Now iOS 6 is not up yet, but it will be here momentarily. And then I can be more specific. I can type in 10.1.0.5, 100.1.0.5, 0.0.0.0, which is saying I want to enable Eigrp on only this interface if it matches this. It doesn't eliminate the other connections, so we do a show run section Eigrp. Give that a couple seconds to pull up. We still have our more specific network statements, and as you can see, this one came up to the top. And if we do show IP Eigrp interfaces, you can see that we've got it enabled for all the interfaces that we said before. So we're in good shape there. And I'm going to come over here and do router 6. Go to global config, router Eigrp 100, network of 100.3.6.0/24. We'll do a 5.6. That'll bring the connection to router 5 up, and then a network of 100.1.0.6, like so. So that should get everything up and running. If I come back over here to iOS 5 and hit the up arrow, I should have a lot more additional routes in the routing table, which is what I want to see. And everything's looking pretty good. So I should have full reachability to everything. Show IP route Eigrp. If I bring this up, I should have a number of routes. I should be able to reach router 2, router 3, router 4, and router 5's loopback. And now router 6, he's there now. And the connection between XR2 and 4 is there. The connection between XR3 and 4 is there. The connection between XR3 and router 6 is there. The connection between iOS 4 and 5 is there. And then the connection between iOS 5 and 6 is there as well. So I can see every route in the routing table. So now if I was to do a ping to 10.100.1.0.5, sourcing from loopback 0, I should be able to ping it no problem. And that's exactly what I'm looking for. That, ladies and gentlemen, is basically how you set up your configuration in order to get Eigrp deployed. That's a step-by-step walkthrough of how to do it. A couple of different variations with the network statements, but at the end of the day, it gets the job done. So if you guys have any questions, please leave a comment in the comment section below. Please be sure to like, share, and subscribe, and I will see all of you in the next video. Thank you.